Welcome Year 11 Maths students. This video is about Chapter 3D, Graphing Parabolas. In this video, we will be based on the turning point form or the vertex form, knowing the key features and how we're going to sketch its graph. Firstly, the turning point form, or we call them the vertex form, written as y equals to a bracket x minus h squared plus k. There are key parameters in this vertex form, which are the a's, h, and k. We're going to take a look at one by one here. Firstly, a. A controls the general shape of the parabola. If you have an a that is greater than 0, you will having a parabola that is a happy curve or a positive curve with the turning point being a minimum. If you have a that is a negative number, less than 0, then your parabola will be upside down or negative with the turning point being maximum. The second feature of parabolas is the axis of symmetry. Because all parabolas are symmetrical, it is important for us to identify the axis of symmetry so that we know where the graph will be symmetrical, as well as to help us identify the turning point. As we can see that the turning point lies on the axis of symmetry, which means they share the same x coordinates. As you can see here, x equals to h give us the axis of symmetry for the turning point form. Next feature is the turning point or the vertex or vertices. It comes with the coordinates h, k. Okay, so h is the x coordinates, k is the corresponding y coordinates. So if you'll be able to recognize the parameters, you just need to simply plug into the formula here to find out the turning point. The next feature is the y-intercept. Is you sub in when x equals 0 into your turning point form here and find out what y equals. So alternatively, you can summarize the formula here by just multiplying a with h squared and then plus k. They will give you the corresponding y coordinates for the y-intercept. Just remember that all parabola will have y-intercept for sure. As for the last key feature here, x-intercept, it does not always exist in parabola. The general form of x-intercept can be summarized as in this form, which is h plus or minus square root of negative k over a, that is the x coordinates, with y equals 0. So what you can see here, we have the square root term. Similarly to what is called the discriminant in quadratic formula, this square root also serves a purpose to help us to determine the cases with the x-intercept. From last year in 10a, we learned that the parabolas will have either two x-intercepts, one x-intercept, or 0 in x-intercept. And from looking at this square root term, inside of it, you have the negative k over 2a. Because this is sitting inside of the square root, the radical, you have to make sure that the negative k over a is going to be a non-negative. Otherwise, will be no real solutions can be found. Now let's discuss with the three cases, one by one. If negative k over a, well, the signs inside the radical, that is greater than 0 or being positive, because we have a negative in the front, in order to make expression being greater than 0, you must have the a and k being different sign. Okay, so a and k must holding a different signs. If a is positive, k must be negative. If a is negative, k must be positive. So that we will have two distinctive x-intercepts for your graph. The second case says, if you have a negative k over a right equals to 0, we know that in order to have a parabola, a cannot be 0. Therefore, k must be equal to 0. If in that case, then we have only one x-intercept since the square root of negative k over a is equal to 0. You plus or minus a 0, which we can actually list out the actual x-intercept, which is h0. Okay, as we know that when x equals h in your turning point form, that actually refers to the turning point as well, okay, where you can see that this x-intercept is at the same time the turning point or the vertex. The last case is where the negative k over a, that is a negative number or being less than 0, and we know that the a and the k must having the same sign. When that happens, negative k over a will give you a negative value. And we know that we cannot have a negative value inside of a square root. Therefore, there will be no x-intercept, as you can see from the graph. Okay, so these are the basic concept and features in graphing parabolas based on the turning point form. Let's take a look about few examples here. Start with example 1. It says sketching y equals to negative 2, x plus 3 squared minus 5. So here I'm showing you the steps I normally do with this question. Okay, you can follow my steps, which basically finding all of those key features, and then you label them on your plan, and finally sketch the parabola. So firstly, we need to identify what is a, what is h, and what is k. In this case, a is negative 2. H, remember, h is going to be not positive 3, but negative 3. Okay, recall that the general formula here is y equals to a x minus h squared plus k. So it's a minus h, which means if you have a plus a positive number, you have to convert into a minus negative number. Okay, so in this case, that we can recognize that h is negative 3. Okay, so k is whatever the number it shows at the back, which is a negative 5. Now, since a is negative number, that tells us you have the set curve with the turning point being the maximum. The second feature, which is the axis of symmetry, that we can, because h is equal to negative 3, and then x equals negative 3 is your axis of symmetry. The third key feature, which is the turning point, again, it's going to be pretty straightforward, which is hk. H is negative 3, k, which is the y-coordinate of the turning point, being negative 5. Next one, we have the y-intercept. So you're going to substitute x equals 0 into the equation, find the corresponding y equals to negative 23. Or alternatively, using my summarized formula here, okay, you always have the x equals 0, and as for y, you times a and h squared plus k, okay? So here you got negative 23. You should get the same answer here, okay? So the y-intercept here is negative 0, negative 23. The last key feature here is the x-intercept, okay? And then I'm going to use this formula here, h plus or minus square root of negative k over a, comma 0, okay? So basically, we're trying to test whether this case will give us x-intercept or not, okay? So know that a is a negative and k is also a negative. In this case, a and k both have the same sign. If we plug in the rule, that will give us a square root of a negative number. And we know that they will not have real solutions for that, which means no x-intercept can be found in this case. Which makes sense. If we collect all those features and label them on the line, you will find out this is the axis of symmetry, which is x equals to negative 3. You have the y-intercept being really below the x-axis, which is 0, negative 23. You have the turning point is also located on the quadrant 3, being negative 3, negative 5. And the general graph of the parabola, it is a sad curve. So from looking at the graph, it is impossible to touch the x-axis, which means no x-intercept. Let's take a look at the second example here. Sketching y equals to negative x minus 3 or squared. Again, the first step is to identify a, h, and k. So here a is equal to negative 1, h is equal to positive 3, k, however, here is equal to 0 because you don't have any constant number after the perfect squares. Now, since a is negative, again, the general shape is going to be upside down with the turning point being maximum. As for the second key feature, the axis of symmetry, we know that x is equal to h, which is equal to 3, okay? Turning point, which x is equals to h, which is 3, y is equal to k. Since we don't have a k, which means k equal to 0. So you have the turning point being 3, 0. At the same time, you can see that is an x-intercept as well, right? The next key feature, which is the y-intercept, what you're going to do is you're going to substitute when x equals 0, you can find the corresponding y being negative 9. So you have 0, negative 9 for the y-intercept. Lastly, we have the x-intercept. Recall this formula here, h plus or minus square root of negative k over a. K here is equal to 0. You will have the square root whole terms being 0. So you have h plus or minus 0 is just h. And we know h is 3, so the only x-intercept is the turning point 3, 0. Okay? So in this case, and we can easily sketch the graph by firstly label the axis of symmetry as well as the y-intercept here. So after these two, we know that the particular turning point is also the x-intercept. And then you need to draw the parabola that is according to the general shape. Okay? Next example, they ask us to sketch y equals to 3, bracket x plus 5 squared minus 2. Again, the first step is we're going to identify the a, h, and k, with a being 3, h being negative 5, and k being negative 2. Firstly, the general shape. Since here a is going to be greater than 0, and you will have a positive parabola or a happy curve, with the turning point being the minimum point. Second feature, the axis of symmetry. We know that x should be equal to h, and h is negative 5. Therefore, the axis of symmetry, x is equal to negative 5. The next key feature is the turning point. With the turning point, we know that it's going to be hk. So h is negative 5, comma k is being negative 2. The next key feature, which is the y-intercept. So again, substitute x equals 0, or alternatively, using my summarized formula here, you should all get the same, which is 73. So 0, 73. Finally, we have the x-intercept. Record that formula here. By substitute k and a, so we can see that because a and k holds a different sign, so after all, negative k over a will be a positive number. And in this case, it is a third. You can see it here, I have simplified a bit, become a square root of 2/3, and I rationalize the denominator. I got a square root of 6 over 3. Okay, so you have h plus or minus, which is negative 5, plus or minus square root of 6 over 3. And then we have the two distinctive x-intercept, negative 5 minus root 6 over 3, comma 0, as well as negative 5 plus root 6 over 3, comma 0. Okay, now, after we label the x and y's on our plane, you sketch the axis of symmetry, label the y-intercept, label the two x-intercept, and then let's find out the turning point, which is, again, in quadrant 3. Okay, once all of those points has been labeled, you're going to sketch our positive parabola that makes sure that the turning point is the minimum. Okay, like so. Well, I hope this video helps you in understanding how to sketch parabolas based on the turning point form. and I'm looking forward to see you in the next videos. Thank you for watching.